Right, so we did a couple homework questions, but now we're gonna continue on worksheet 8. Remember, guys, quick reminder that chapter 2 expires before Thanksgiving, so get on top of that. If you have not picked up the remediation, at least do that today so you can get on it this weekend. So yesterday we talked about applying the one-to-one property of exponential functions. Those were the kinds where we made the bases equal. So like we had 3 to the x, and over here we had 9 to the 2x minus 5. And so we said, well, this is really 3 squared. So we could set that exponent equal to, and we multiply this, so it's 2 times 2x minus 5, and then we'd do some fun and that would come out really ugly, okay? That was that property. Today we're gonna apply the one-to-one property of log functions, and we're gonna learn some crazy weird factoring options. So if you could just look at example B on the front side of worksheet 8 that I skipped yesterday. Do you remember, I just want to take you back for a second, when we had like x to the 4th minus 4x squared plus 3, and we factored that as x squared minus 3 and x squared minus 1. Does anybody remember those kind of factoring problems? Where we did the crazy x to the 4th and we factored it x squared and x squared. That's kind of what we're doing here, except our weirdness is going to come in the form of this is e to the x squared. So this is e to the x squared. Does everybody get that? Because that's a 2 times x, right? And this one is minus 3 e to the x plus 2 equals 0. So most students, for some reason, they can get this without doing any crazy business. But over here, most students like to substitute this. So they will do something like let u equal e to the x, and then they will call that u squared minus 3u plus 2. If you want to leave it e to the x, it's all good. But how would that one factor with u's, guys? U and u, and 2 minus 2 and minus 1 to make a negative 3 and a plus 2. So then you have to sub back in the e to the x, though. E to the x minus 2 could equal 0, or e to the x minus 1 could be 0, right? Because we have this could equal 0 or this could equal 0. Now, how do you solve when there's an x in the exponent? You have to take the log of both sides. So I'm going to do ln on both sides. And then I'm going to move this guy out front. And what is ln of e? So we just have x equals ln of 2. Or over here, we'd have this. And ln of 1, this would be x moved out in front, ln of 1. Okay, one of those simplifies and you should know what it is. Anybody know which one? I mean, you probably guessed this one, but e to what power is 1? 0. Okay, so this is just 0. This one is an exact answer, so right now, x could be ln of 2, or it could be 0. But you're also okay to give me an approximate answer. Anybody type ln of 2? I saw you type in Destiny. What'd you get?
0.693.
So if it asked for an exact answer, you would say ln of 2. If it asked for an approximate answer, 0.693. And this one had 0 as a solution too. Most of the time you'll get 2 decimals. All right, so that was kind of weird. Think you can try that? How far did we go yesterday?
We've got
Okay, this is one of those, right? Oh, what can we do first on number 4 here? Take out a 2, right? So we, just to make it more complicated, we have a 2. And that e to the 2x is an e to the x squared. It is 6 e to the x, because we took out a 2. And half of 54 is 27. Did I do that right? Someone? Okay. All right, now, we could get rid of this 2 right away, yes? Because can 2 equal 0? No. So then I have this left, and if e to the x were replaced with a u, I don't know why they always use u for these, but they do, and we do a lot of them second semester, so we call them u substitution problems, so I'm just going to stick with u. This one would be a u squared. This one would just be a u. Okay, how can we factor that? Now, if you want to solve them first, so you want to say u is -9 or u is +3, everybody good? Before you substitute back, that's fine. But some point, you got to substitute back and say e to the x equals -9 and e to the x equals 3. And you got to remember that you're not done, because I don't want to know what e to the x is. I want to know what x is equal to. So then you have to take the log of both sides. Anybody seeing a problem? Yeah. This is just going to move out front, and we're going to have x times ln of e, which is 1. Can we take the natural log of -9? No, this guy is just going to be not possible. Ooh. That's not nice, clear notes, Hofbauer. Let me try that again. Over here, we move this out front, and we have x ln of e is 1 equals ln of 3 is the exact answer, or Destiny? 1.099. Okay, so there's our answer, exactly or approximately. It does say here that you could graph this, okay? Unfortunately, on the quiz, it does say find an exact and approximate answer for this kind of question. If you graphed this, you would get only the one solution, okay? They didn't do this exact question, but they graphed one, and you would get the decimal approximation. So if we graphed ours right here that we started with, we should get the only place it equals 0 is 1.099, okay? All right, then we did 5 and 6 yesterday, didn't we, in this class? Yeah. Okay. Everybody remember what we did? X was in the exponent on both, right? So we isolated it, and then we took the log of both sides, messed around. Oh, good, we have some more practice. Number 7, my first thought was, oh, we can rewrite these, but is that going to work? No, because 6 is not a power of 3, right? So we do have to take the log of both sides. Anybody care which one we do? Should we do log just to be different? Move that out front, and then we'd have times the log of 3 equals, over here, if we move that exponent out front, it is a quantity that we're multiplying by, and the log of 6. What are we going to do to that mess? 2 times the log of 3 is some number, right, guys? And that's multiplied by an x. Over here, if I distribute that, I have the log of 6 times an x. Where do I put the x? Yeah, it is in front because it's not a log of 6x. The log only applies to the 6. So it's x times the log of 6. And then the log of 6 times 1 would just be minus the log of 6. Okay. Ideas now? I think we could have just changed this out to decimals from the beginning. What do you think? Because I don't think it's going anywhere nice. We need to subtract this over to this side so all the x's are on the same side. So I have 2 square roots of, I'm sorry, I can't read. 2 times the log of 3, that's multiplied by an x. And here I have minus a log of 6 that's multiplied by x. So I could write this at the back. So can I combine those because they're both x's? You could write this if you were really worried about being exact. All of that is multiplied by x, and left over here is this. So then what are we going to end up doing? Dividing. Can we just go back and use decimals? Okay. Let's just go back right about here and use some nice long decimals. What is 2 times the log of 3? I didn't get my calculator out, did I? How many 3 is probably okay, because I don't think they even said 3 on the top, did they? 2 log 3, is that what we just said or not? 0.954, we good on that one? So we have 0.954x equals, what is the log of 6? Okay. 0.778x and minus 0.778, right? Now it's messy, but can we do that? We just need to combine our x's over to one side. Don't make me subtract. 186? How did I do? Yeah, forget I borrowed. I was trying. 176x equals negative 0.778. Okay, I'm not dividing in my head, guys. Negative?
Yes, negative.
Okay. Yeah, let's go back and try that. 3 to the power of 2 times, was it roughly 4.4? Okay, gives us that. On the other side, it was 6 to the power of 4.4 minus 1, right? Now, oh, it was negative 4.4. Thank you. I'm like, I knew they weren't going to be exact, but I didn't think they were going to be that bad. All right, let's go back here. Because, yeah, something's got to be wrong. They can't be that far apart. All right, let's insert a negative. And then go to this one and insert a negative. Now, they're both basically 0, right? But they are very close to the same number. Okay. So the answer was, just one more time because I didn't write it very clearly, negative 4.42. All right. Yikes! Is the next one better? Why is the next one so much better? Yeah, we have to take the log of both sides, but the natural log of e is just 1, right? So we'll be much better off. So we have ln of e, the 19 will move out front, 19x, ln of 23. This is just 1. So to get x by itself, we need to divide by 19. So there's an exact answer. Or natural log of 23 divided by 19. Did I remember it right, guys? 0.165, anybody? Okay. Yeah, 7 is definitely evil. We could have changed from the very beginning to decimals, but it's still messy. Okay. Number 2 is about when you have multiple logs. It says anytime you can say the log of something with the same base equals the log of something else with the same base, so you have a single log on both sides, okay? That's only true if the quantities are equal. So if I have the log base 6 of x minus 4 equals the log base 6 of x squared plus 5x, I can just get rid of this because there's exactly 1 on each side. And then I can move it around, make it equal to 0, factor, etc. What I can't do, and I need to stress this because students do it all the time, ln of x plus ln of 2 equals ln of x minus 7. Can I just get rid of all those ln's? No. I can very easily because I can combine those into a single one, right? And then I could get rid of them. But I have to have exactly 1 on each side before I can cancel them. So this is not that kind of question at all. Can we re-isolate the log? This is a strategy we used yesterday. When there's a single log expression, we're going to isolate it. Now, this confuses me because they don't use parentheses, but this is what it means. So what do you want to do first? Add 1 to log base, Hello, internet, hello. Okay. 2 log base 5 of 4x equals 12. Then we need to divide the 2 off. Log base 5 of 4x equals 6. Now, yesterday I made a big deal about, I like to think of this as rewriting. I think of it as 5 to the 6th power equals 4x, right? But some of your teachers last year probably just taught you to do this, what they called exponentiate. Did anybody's teacher do that? So then they said this and this undo each other. So you end up with 4x equals 5 to the 6th. That kind of feels like magic to me. You can do it. I'm good with it. But to me, it makes sense that I'm rewriting it. 5 to the 6th power equals 4x. It's exactly the same thing. Okay? I don't care which way you do it. All right, so somebody want to do 5 to the 6th and then divide it by 4 and tell me what we get?
3,906.2.
When we're all said and done, it was 3.
906.2.
3906.25. All right, everybody good? I think that was probably done for you, yes? Oh, there, what do you know? Okay. I don't know if this one is done for you as well. There is a trick here. I can't get rid of these logs because of this. And I'm not going to be able to get rid of them at this point because that doesn't have a log at all, right? I can't combine it. Can I add this log over to the other side and then maybe use my properties of logs to combine them into a single one? Log base 2 of x minus 6. It was a minus over here, so I'm going to add it to the other side as a log base 2 of 2x. And that left the 5 all alone over there. Then what can I do when it says plus with 2 logs? Yes, but unfortunately, That does leave an x minus 6 times a 2x. Okay? You want me to write it like your teacher last year did? Or you want me to think of it as a rewrite? It's 2 to the 5th, right? Equals all of this. Can we distribute that before we write it down to save a little? 2x squared minus 12x. Okay, please tell me you know how to solve a quadratic. What do we have to do? Get it equal to 0 first. 2x squared minus 12x minus 32? Okay, first thing we can do is take out a 2. X squared minus 6x minus 16. What are the factors of 16 that are going to help us? Do you see me trying to extend that page? It's not working. 0 equals what? 4 and 2 doesn't make 16. 4 and 4 aren't going to make 6. Minus 8 and plus 2, does that make a negative 6? Okay, now, can 2 equal 0? No. Can this equal 0? If x is 8. Can that equal 0? Yes, if x is negative 2. Now, I think we should go back to the beginning, because I don't remember what this looked like. Can we put a negative 2 in? Can't put a negative 2 in. Can we put a 6 in? It didn't have a 6, it had an 8. Can an 8 work? Yeah, I think 8 is fine. But it cannot be this, okay? It says, well, it is always a good idea to check your solutions to any equation. This is especially true of logarithmic equations, since log functions are only defined on the set of positive real numbers. But remember, we did talk about sometimes x can be negative depending what the question looks like. If it had said log of 3 minus x, we could definitely put a negative 2 in there. So be careful. Don't get to just always throw them away. All right. Here we go. Oh, what's happening on number 9? Single log on both sides, right? If you want to think of it as an exponentiate, it's a base 10 on each side, so we just have what? Equals 12, x equals 4, we're golden. Can we do that on number 10? No. We got to combine them first. What happens here? Log base 12 of plus means multiply, so we get 2 times x. Log base 12 of x plus 7. So the only way that's true is if these are the same quantity, or some of you could think of it as do this on both sides. But that, again, that only works if you're doing it once on each side. So we end up with 2x equals x plus 7 or x equals 7. Can I put a 7 back in? Yeah. Oh my goodness, why do I feel like I'm gonna need a lot of paper? Okay, we'll see. If it starts getting long, you might have to skip some of the showing work. What does plus mean? So we have to multiply these together, 16x plus 2 and 20x minus 2. And thankfully there's only one log on the other side. 319x squared plus 9x minus 2. Okay. We can get rid of these guys. If we multiply 16 times 20, anybody? 320x squared. That would be a plus 40x and a minus 32x. And then 2 times negative 2 is a negative 4. 319, x squared plus 9x minus 2. All of a sudden, I'm happy to see a 319, yes? So if I subtract all of these, over here I'll get 0. Over here I have a negative 2. 40 minus 32 is 8 minus 9. Anybody get a negative 1x when they did it?
Yes.
And a positive x squared. Went from huge numbers to really little numbers. X minus 2, x plus 1. I didn't need as much room for work as I thought I did.
Right.
X equals 2 or negative 1. If I go back to the beginning, can 16 times negative 1 plus 2, that'd be like what? Negative 14? Can you take the log of negative 14? Everybody good? All right. What about 12? We can combine these into ln of what? Plus means, so we have x times x plus 16. Over here, plus means multiply. All right, then I can exponentiate or use the property of equal logs to get rid of those. If I distribute the x, if it's a quadratic, it's got to equal 0. Did I move everything over correctly, guys? Anybody else get this? Because that doesn't factor, does it? Yeah?
8 times 6.
Oh, 8 times 6. Thank you. Like, this is not working out very well for me. Thank you, thank you. This is 48. So when I move it over, it's minus 48. 48 has a lot of factors, 2 of which are, what are they? 12 and 4, that will work. Thanks, Jacob. I was panicking. I was like, I don't want to do quadratic formula. X equals negative 12 or positive 4. The very beginning, wasn't there a ln of x? So we get to throw this negative one out. The answer is x equals 4. All right, is there more factoring? Well, maybe not. Application. The amount of radium A present in a sample after T years is given by this crazy formula where A sub 0 is the initial amount. So how long will it take T grams to decay to, or 50 grams to decay to 10 grams? I'm sorry, I'm making things up now. Which of those is A sub 0?
50.
Yes, this is the original amount. This is the amount we want to have at the end. What are we trying to find? T. All right. So we have 10 came from 50 e to the negative 0.00043 t. What do we have to do first? Divide by 50. And you can get that, I think it's just 0.2. And then what are we going to do? Natural log of both sides. And this is gonna move out front. So we have the ln of 10 over 50, which like I said, I think is 0.2. And over here I have negative 0.00043t times ln of e, which is just 1. So only step left is to divide by that negative lovely decimal. ln of 10 divided by, what did I just write? 50. And then I totally lost my train of thought. Oh yeah, divided by the whole thing, negative 0.00043. Anybody else get 3,743 years if I round to the nearest year? 3743.
40 grams to disappear for over 4,000 grams.
Yes. This is all about radioactive decay, guys, and this is why radioactive material is scary, right? Because it takes so long to lose its radioactivity. Okay. Richter scale also uses logarithms. E is the energy in kilowatt hours. If we have a 6 on the magnitude, where does that number go? Magnitude of, so we have 6 equals 0.67 log of 0.37 E plus 1.46. Okay, that E is not little e natural log, right? Okay, where do you want to start? Yes, algebra says get rid of any adding and subtracting first. 4.54? 0.67 log of some garbage that we can't worry about yet. What do we do next? Divide. So left over here we have log of some garbage equals some crazy number, and I don't know what that is. Did I type it right, guys? 4.54 divided by 0.67. Okay, I got 6.776. It's a pretty number. Now what? How do we get rid of a log when there's a single one? Yeah, we rewrite it or exponentiate. What is the base? So we're gonna have 10 to the 6.776 equals 0.37e. Okay, that's gonna take some typing because 10 to this is gonna be a giant number, right? And then we're gonna divide it by 0.37, which is actually gonna make it bigger.
So
10 to the 6.776 is this big number, and then we're dividing it by, what was it?
0.37.
Okay. 16 million?
Yeah.
Okay. That is a big number. Can I just do this long enough to copy that number down? So the energy created is 16,136,089, if I round to a whole number, kilowatt hours of energy. Yes, yes, it is. I do not want to be around a 6.0 earthquake anytime soon. I don't know about you.
Yeah.
Okay. I have a couple, well, just one example. Can you help me do this one quick, guys? What do you do when it says plus between two logs? Yeah, you rewrite it. This would be log base 12 of 12x times x minus 1 equals 2. And then what do you do when you have a single log? Rewrite it or exponentiate, so you would have 12 squared equals 12x times x minus 1. Before you did anything too crazy, before I even distribute, could I divide 12 on both sides? Yeah, I actually could. You could distribute it, but eventually you'd be able to divide it out. Factor it out. So we have 12 equals x times x minus 1, or 0 equals x squared minus 1x minus 12. That's going to factor minus 4 plus 3, which gives us negative 3 or 4. Both of those going to work? Yep, not the negative 3. All right, got it? Little practice? Okay, so what you need to do are these problems. Now, on 11, oh, this is really Monday's assignment. So this weekend, what you need to do is this bookwork on page 196, okay? It's attached in the Google Classroom if you don't want to dig out your book.